Hey everybody, this is Mr. Beckstrom, and today I want to take a look at an example from section, this is 5.5. Yeah, this is on use substitution for integration, definite integrals. And I'm looking at an example that's similar to number 24 in the homework here. And I wanted to go over a little bit of the thought process and the strategy and a couple of the different ways that we can actually solve this once we do our use substitution. So the problem says here, use a change of variables or the table to evaluate the following definite integral. We're going to use a change of variables. So the idea with these types of problems is that they're designed in such a way that that we can pick one thing to be our u. And then once we take the derivative of that u, whatever that derivative of that u, that also is going to either be in there or a multiple of that is going to be in there. Basically, that times a constant is going to be in there. So if we look around, it's not going to be too hard to find that if you look at this x cubed minus 1, and I'm just going to kind of do this off to the side. If you look at that x cubed minus 1, if we take the derivative of that, that's going to be 3x squared, right? And if you look at that, we also have an x squared in there, and that x squared, right, that's just 3 times x squared over here, right? So that's a great choice here because this is just a constant times something that we already have in there. And that's really almost all the time what we're doing with these u substitutions is that we're trying to find a u that when we take the derivative of it, that derivative is also in there either just like it is or times some constant like this, right? Because we can easily move that constant around, divide it by both sides, pull it outside of the integrand here, and work with it. We don't really care about constants, but we can't do much with extra variables. So that's why they design these in such a way that the variables are kind of non-negotiables, but the non-variables are very negotiable. All right. So what we're going to do here then is we're going to say we're going to let u equal that x cubed minus 1. And once we do that, then our derivative of u is going to be equal to 3x squared, just using the power rule, dx, right? That's just the derivative with respect to x there. And then, but look, I have an x squared dx, so I don't want that 3 in there. So I'm basically going to divide both sides by 3. So I'm going to get 1/3 du is equal to x squared dx. Basically, when I do my substitution, I kind of want to keep it clean. I want to get rid of everything in here that I can. So the last thing I want to do, and this is kind of a personal choice, you can do it either way, is I can also replace the limits of integration, go from the x world into the u world. And if I do that, the great thing about that is I don't have to go back to the x world once I find the antiderivative. I can just keep it in the u world. And that's going to make it easier later. And the decision behind that is whether or not it's kind of an easy substitution. And I use this right here to kind of decide. So this is this 1 and 2 is in the x world. So if I plug the 1 in here, x cubed minus 1, that's just going to be 0. So that would change. That would go from 0 to, if I plug the 2 in there, that would be 2 cubed 8, 8 minus 1. That would go from 0 to 7. So I'm going to go ahead and do that. So that changes. The x world goes from 1 to 2 to the u world goes from 0 to 7. I'm going to put u here. So that means that if I change my limits of integration from 1 to 2 to 0 to 7, I don't have to go back and substitute back in my x's after I find the antiderivatives because I have changed everything over to the u's. Now, I don't have to do that. I can leave it the 1 to 2, but if I leave it going from 1 to 2, then after I do my antiderivative, then I have to go do that substitution back into the x world. So that's a choice that we can make. We can make it separately for different problems, but if you go into the u world, then you stay in the u world. If you keep in the x world, then you have to substitute back into the x world. So if I'm going into the u world here, so I'm going to change these limits of integration from 0 to 7 by using this function right here, the substitution that I made. So now, what does that mean? Well, that means that I'm going to go make my substitution. I'm going from 0 to 7, right? All right, let's see what my substitutions look like. Okay, so this is my E. I still have the E here. This is U, right? And my x squared dx becomes 1/3 du. So the 1/3 I'll pull out to the front, and the du I'll leave inside, right? So I made all my substitutions in here. So my x cubed minus 1 became a u, and my x squared and my dx, my x squared and my dx became a 1/3 du. The 1/3 I pulled out front, the du I left in, and now, and I also substituted my limits of integration from 1 to 2, going from my u world 0 to 7. And now I'm totally in the u world. I never have to look back. So now I've got this nice, easy, definite integral from 0 to 7 of just e to the u. And that's it. So now that's just 1/3. We're going to take the antiderivative, and the antiderivative of e to the variable is just e to that same variable, right? E to the u. We're going to evaluate that from 0 to 7 using the fundamental theorem of calculus. So that is just going to be, this is already the antiderivative right there, so that's just going to be 1/3 e to the 7th, right? Evaluate minus 1/3 e to the 0, and so we just got to clean that up a little bit, right? So that is 1/3 e to the 7th minus e to the 0 is 1 minus 1/3. Right, and oops, is that right? So I can just pull out a 1/3, I think. So that would be 1/3, and then e to the 7th minus 1. And I would probably leave it like that. I think that's probably fine too, but either way. And that's your final answer right there. So, like I said, we had a couple of choices to make along the way. I generally like to change over to the U world if I can. It makes things usually easier down here. If I did not change over to the U world, I would have left it 1 to 2. Then when I got down here, I would have had to substitute the x cubed minus 1 back in here, and then I would have gone from 1 to 2. And I would have ended up getting the same thing, but it would have been a lot more messy. All right, if you have any questions, let me know, and I hope you have a great rest of your week. Thanks.